So welcome to our week 4 webinar. I'm Taylor.
I'm Shawna.
And today we're going to be covering the topic of differentiated instruction. So before we start, we're going to do a little bit of a warm-up to get us going here. Can any of you tell me what differentiated instruction is or what it means to you? Yeah? Awesome. Anybody else?
But
Yeah, absolutely. Those are all really great answers. So differentiated instruction does differ from classroom to classroom and student to student, but the main thing is that each classroom should incorporate differentiated instruction for some of the reasons you listed. So for equal playing fields, to make sure that each student has an equal chance at success, and ultimately to understand where students are and to help them better succeed in their learning for their long-term education plan. So what we're going to be doing today for our warm-up is I've sent you all a link to an EduGains website where we are going to kind of take something similar to a personality test, but it's actually called What Type of Learner Are You? So multiple intelligences, the self-assessment from Edutopia. So if you can open that link now. So what it's going to do is it's going to ask you 24 questions and will take a couple minutes to complete. Try not to think too hard about the questions. It's going to prompt you to answer some questions about yourself, how you feel about others, the world around you. And at the end of this, you're actually going to figure out what type of learner you are. So you can pull that link up on your phone and Shawna and I will hang out and wait for you. All right, so when you're done, no rush. You can just give Shawna and I a thumbs up so we can see that you have completed that task. You're all good? Perfect. So what I would like you to do is just kind of share your results. So it's split it up into some categories, and I'd like you to just kind of share, if you're comfortable, with what you got and how you think that relates to you. So some personal examples. Who would like to start?
In like kinesthetic learning and naturalistic learning. So by being in the real life situation and being that can like help my real life directly. Yeah. Which I think a lot of students have that.
Awesome. Anybody else? So communication based, so if you're given instructions or a detailed explanation, that's how you learn better as opposed to something that is more open-ended, kind of free range. You like that structure and that communication. Awesome. Anybody else? Nice. Mm-hmm. Awesome. Robert?
What?
Awesome. So that was a really quick way to do that with adults. Obviously with kids, you wouldn't really do this. This is pretty intimidating, but it does show you how different we all are as learners. Clearly we're all in the same program. We're all working towards the same goal, but we all learn a little bit differently. I personally learn better from pictures and hands-on. I'm the spatial awareness and as well as naturalistic. So anything with being outdoors and connection to the world around me is really what helps me learn personally. Shawna?
I'm more of a bodily kinesthetic person, so I actually like to get involved with what I'm doing rather than just reading something. I need to actually experience it for me to understand what's happening.
Absolutely. So those are super important in understanding your kids. But with kids, obviously what you would understand or something you try to do is at the beginning of the year, hand out a get to know me sheet. Yes, you obviously want to know about a little bit more about them, their favorite food, their favorite color, their favorite subject, things like that. But really getting into the nitty gritty, to ask kids how they want to learn. Ask them if they like to physically do things, or if they like visuals, or they like music or math, or maybe are a little bit scared of it, things like that. That's how you kind of get a general understanding of your class before you even start teaching. Because as a teacher, you really need to gather that information to have a successful year and have successful students in both their academics and in school, in the real world, as 21st century learners. So what I'm going to ask you now is in terms of math specifically, how do you like to learn? If you don't like to learn math, that's okay. If you are visual, materialistic, you would rather learn it through pictures or manipulatives. Tell me a little bit more about how you personally like to experience math and work with math, whether it's in the classroom or in the real world.
So I personally hate using manipulative and pictures. If I look up the wall, I cannot get it, and like I do that, stare at it and just like problem solve in my own brain and kind of figure it out. I can't I don't like pictures. Which is really funny because I'm the complete opposite of that. So I need to hold something in my hand. I need to see how it's directly impacted in my life and how I can apply that to the world around me, or my brain automatically goes to why do I have to do this? I'm done with the same on this one where I need to be able to just sit there for a little bit, especially I love working with people on a problem, but before I do, I need a few minutes to think about the problem myself first, because I just get sort of
Absolutely. Robert? Writing it down.
Okay.
Right, so we, just like in a similar classroom setting, everyone who's participating in the webinar has different views, different ways they like to learn. Again, I would say visual. I don't necessarily need to be holding something, but I need to see it in terms of pictures and the numbers I'm given, or the way that I can present what I know. I prefer visually. Shawna?
Yeah, I'm more of an interactive person, so if I can apply it to the real world or see a real life situation and then do that myself, that's how I learn the best.
What we're going to be doing now is we're going to be moving on to our do activity, which is this math webinar worksheet. So we're going to be starting on the side that says number sense and numeration. So a big thing with differentiated instruction is a lot of teachers think that if you're differentiating instruction or kind of chunking things, that you're losing a lot of curriculum connections and content. That isn't the case, and I want to clear the air about that right now. Just because you're differentiating instruction doesn't mean that you're cutting from content or learning or anything like that. You are just differentiating the way that students learn and what you expect in return. So at the top of the sheet, you see some curriculum connections, and by reading those over, you can see that we're working with decimal numbers, the representation, and money value, which is super important in the 5th grade, and obviously in life. We use that every day. So what a non-differentiated task is what we're used to seeing, because that wasn't a huge thing when we were in elementary school or the 5th grade. as a matter of fact. So that's when the numbers are plugged in for you. So the question reads, Christine bought 7.6 meters of fabric. The total cost of fabric was $27.32. Estimate the cost for each meter and explain your strategy. So with this, students are given the numbers, they're given what they're asked, and they go for it. However, that might deter students from even trying to complete this task. We know that mistakes are good for the brain. They help you grow and understand and really contextualize math in a real life situation. So what we're going to be looking at today are open tasks and parallel tasks. So open tasks is the same question, but all of the numbers and numeric values are removed. They're blank, so students can fill them in if they want to challenge themselves, or if you want to see where a student stands in terms of their academics or what they need to work on for personal goals. So the meters of fabric is blank, and so is the cost. So students are encouraged to work within their comfort range or try something new. However, they're still learning the exact same curriculum connections that are connected at the top. They're just doing it at their own pace. And if it makes them feel more comfortable about what they're doing, they're more likely to do it. If you give students numbers or equations that frighten them or look scary, they're probably not going to try. So you want to ease students into this, especially in the 5th grade. Younger grades of JI, they need that to kind of understand where they stand in math and what they prefer and ultimately what type of learner they are. So equivalent to that, it's called a parallel task. So parallel task isn't exactly open. It isn't exactly all put together like our non-differentiated tasks. Usually one of the number allotments or slots is blank. So if you're looking at the question here, either the meters is blank or the cost of the fabric. So students will be able to put in whatever, however many meters or what the cost of fabric is on their own. So this relates to real life connections, similarly to Sam and Gio's math webinar last week when we were working with carpet. Really contextualizes, wow, if I need carpet, I need this much. So it's that real world application that really gets students going. So giving them the opportunity to say how they want to do their math and how it makes them feel comfortable or it doesn't or what have you, that's really important to students. They want to be comfortable doing math, so let them have a say in what numbers they choose. And that's a really great form of differentiation in math. So what we're going to be doing is Shawna and I are going to be asking you to complete one of the 2 differentiated tasks of the parallel tasks. So you can either pluck in the number of meters or the number of, or the cost of the fabric. Everyone got that?
Cool.
Okay, awesome. We will give you a minute to do that and we will check back in. And we are back. How did that go for everybody?
It was good, yeah.
Awesome. Does anybody want to share which question they chose and how they chose to estimate the cost per meter?
Well, I'll start. So what I did is I chose the total cost of the fabric, and I made it $20. And so then I took the 3.7 that Christine bought of meters, and it's close to 4, so I rounded it to 4.
Mm-hmm.
And I took the total, so the $20 divided by 4 to get how much it costs per meter, and that was about 5. And then because I know that 4 is a little more than 3.7, I rounded it. I just brought it down a bit, so I ended up with $4.5 per meter.
Awesome. That's a great way of doing it. Did anybody do that similarly? Was that a common method for anybody?
Mm-hmm.
I
You
also
also
rounded down. I had 3.7 meters and I made it $30. So I subtracted the 0.7 and divided the 30 by 3. So it was 10. And it was about 2 cents off. Or $2, sorry, not 2
I
cents.
was like, yeah, $2 off. That's a really great way for estimating. Did anybody choose to put in, sorry, you put in the meters of fabric, right, Brittany?
Yes.
And
Or no, I put in the amount.
dollar amount. Did anybody put in the meters
Mm-hmm.
of fabric?
I did.
Awesome. And you used a similar method, Michael?
Yep. I chose 4.9 meters, so it's very simple just to round that up to 5. And so $16.98. That's close to $17. 17 divided by 5 is just over $3. So it estimated really nicely like that.
Awesome. So we are going to flip around to the second question, which is similar, and then we'll have a little bit of a discussion and reflection after that. So Shawna's going to lead this one here.
So now we're focusing on grade 5 again, but this time measurement. And what we're going to be looking at is estimating measurement in regards to time. Okay, so we're talking about time with minutes and hours and days and weeks. And for our non-differentiated question, it is: a spider took 36 minutes to spin a web. The spider finished spinning at 8:10 a.m. What time did it start? So now our open task, we're removing those two time values. So we're no longer looking at minutes or no longer looking at the time of the day. And then for your differentiated parallel task, which you're going to choose, so you can now either choose to input what time, or you can choose to input how many minutes the spider was doing that. So you can go ahead and read your parallel tasks and pick one and then do the exact same thing again.
Awesome. Thumbs up if we're done.
Good. Okay, so would anyone like to share which question they chose and what they did choosing their numbers?
I'll go first.
Okay.
So I did the first one. So a spider took 45 minutes and then finished spinning, I said at 10 a.m. So basically, like, the way I work it out in my head, I did like 10 a.m. minus 45 minutes and then equals 9:15. But the way I work it out in my head is like I always do like 15-minute increments because I find that they're easier to add. So I started with 9, then 9:15, so adding that, and then whatever added up to 45 minutes because like 5 plus 5 is 10, and then 1 plus 1 is 2, plus 1 is 3, and then kind of worked my way up from there.
Awesome.
Nice. Anyone do anything different? Anyone do the same thing?
I did probably roughly the same thing.
Mm-hmm.
Yeah, I did the same. I also did roughly the same thing, except I tried to like visually put it on a clock, but I ended up confusing myself, and I used 15-minute increments to figure it out afterwards, and that's how I got my answer. So I tried to make it visual, but then it sort of backfired and just went back
But
to
that
the way that I knew it.
Mindset. It confused you, and you still kept trying.
I did.
Observation.
Did anyone do the other question where you put in the amount of minutes?
Choose the minutes.
I did that question similar to them. I solved it in a very similar way. I said the spider took 75 minutes to spin the web, and it started spinning at 11:40. So I just subtracted an hour away from 11:40 first to get 10:40, and then once I did that, I just subtracted 15 from 40 to get 10:25.
Awesome. So we saw a lot of chunking and breaking down numbers with number flexibility. So how you feel comfortable with working with numbers. That's a big thing with differentiated instruction as well, is letting students play with their numbers. That's not something you see in classrooms often. So if students want to break it down into 15-minute increments, or I personally would do it as like 30 and then 15, but I guess that's essentially the same as like 15, 15, 15, or trying to visualize or things like that. So letting students have that opportunity to kind of do the parallel task the way they want. So expanding on it.
Yeah, it allows you to look at the problem and see what the problem's actually asking you and how to go about solving the problem without being stressed over what numbers are given. So you're allowed to choose your numbers so that you feel comfortable working with the numbers, and then you're more motivated to solve that question because you're doing it in a way that you can while learning how to solve that problem at the same time.
Absolutely.
Moving on.
Okay, yeah, so we're going to move on to the last part of our worksheet. And for this, we're going to be looking at grade 6. So we're moving away from grade 5, getting a little bit higher up, and we're going to be working with data management and probability. So this is something a little bit different in terms of what we were doing before on the other worksheets, but essentially it's the same concept. We are working with parallel tasks. So we don't need to show you the difference between an open task and a parallel task anymore. You guys are rock stars on that. So we're going to get right down to the curriculum connections. So we're determining through investigations how a set of data represents population. And we're going to compare graphical representations of the data. So that's a really big expansion onto this worksheet itself. And we're thinking about that in terms of we're not trying to cut down the curriculum of what students are learning just because we're differentiating it. That is not what we're trying to achieve here. We're trying to give every student that equal playing field, like Brittany was saying when we talked about what differentiated instruction is and how it affects all of us and our classrooms. So for this one, I'm going to ask you to fill in a number right here, where the blanks are. Around 10,000, any number you want. In the 6th grade, they go up to 100,000, but for our sake of our workshop, we're only going to make it into the tens of thousands. So I'm going to give you this time right now to just fill in any number, the first number that pops into your head. Don't think about it too hard. So you're a student in the 6th grade class. You finally get to fill in your own math sheet, and it's not about answers. It's about you being a part of the problem. Which is good for this. Sounds funny. You were a part of the problem. Okay, does everybody fill in a number?
Yes.
Okay, awesome. So as you continue to read on the question, it's not a trap, so don't get freaked out. It says, on this day at Brock University, a fifth of students, so the number you wrote down was actually how many students in that sentence. So a fifth of the students were in residence, 3,476 of them were in the library, 492 of them were in the market hall, and the rest of them were in Welch and South Block. So now with that number that you put in yourself as a student eager to learn math, is you are going to follow the rest of the question and you're going to place the students in their appropriate buildings and show your work below. So again, for our visual learners out there, we added a little bit of a map here to kind of show you more of a visual of what the question is asking for. And then for students who need clear instructions, similar to, I think it was Gio or Sam, who said they like when things are laid out by communication. So there's a really easy, simple box here for you to put in your numbers. So you can take the number that you picked and work along this problem by solving it through differentiated instruction through this parallel task. So we will give you a few minutes to do that. Just remember that you're reading the question in its entirety. So starting with a fifth and then moving down and then splitting up the rest of the students. And we'll give you some time to do that. And when you're all done, you can just give us a thumbs up so we know.
Is there supposed to be an equal number in Welch Hall?
Yes.
So an equal number.
It doesn't say that.
Oh, okay.
The rest of them.
The rest of them. So you can place them where you'd like.
Oh, you like, okay.
Okay. So we're going to check back with you after completing that differentiated task, the parallel task of data management. So we were looking at where to place people in appropriate buildings. I'm really interested to see the number you picked and how you worked through it, because obviously for each student, this experience would be very different depending on the number they picked. And at the end, Michael actually caught this when I asked, or when I said that the rest of them were in Welch Hall and South Block. So I wasn't saying that it was split equally or whatever. So students could really be wherever they wanted, or students could really put the Brock students wherever they wanted them to go. So not only do they have to say in their number, but they get to have a little bit of fun, because at the end of the day, that number doesn't necessarily mean a whole lot in terms of the problem, what I'm asking the students to do, but it's important for them to, again, have that say in math, that differentiated instruction. It may not seem like it, but this is helping students be more comfortable with math, and that's really important in junior intermediate, because if you block that out and they get a little bit scared of math or frightened with the numbers, it's unlikely that they're going to pursue something like that in high school or university and really contribute with their 21st century skills. So it's important that they have that say. So I'm interested to see how everybody did theirs. Would anybody like to share?
Me.
All right, Brittany, take it away.
Okay, so this is what mine ended up looking like. I don't know if that's super confusing for everyone, but I mean, worked for me. So what I did was I started with the number 6,732, very specific. And then I figured out what 1/5 was in percentage and turned it into a decimal, and then worked out what percentage of 6,732 that was. And then I put all of them in residence. And then I like slowly took away however much I had left over. And then my ending number after I put everyone where they needed to be was 1,418. So I figured since South Block was bigger visually, that means that the bigger number should go there and the smaller number should go in Welsh Hall.
That's awesome. I like that you use the visual representation, the map, to actually just kind of guide your thinking in a way you may not have thought, with students just giving them a number and just having them pluck it in right here in the box that we provided. May not be that stimulating, but I think that's really interesting that you were able to make those connections. So again, that's a real life connection. If your students are looking at building sizes and seeing how many people are in there, it's connections in math on paper to the real world that they could use every day, depending on their career or just in everyday life, whether they're picking the grocery store or the mall or whatever, just by size, estimating that in terms of population. Awesome job, Brittany. Anybody else want to share? The exhale, Michael. You ready to speak?
Yeah, I did it in a very similar way to Brittany. My number originally was 12,674. So I just started off just by dividing that by 5, but you could, another way of doing it would be to, instead of dividing it by 5, if you don't like division, you could multiply it by 0.2 instead. That's sort of like a percent. But yeah, that gave me my number, and then just like how Brittany did it, I just did it the rest of the way like that, slowly dividing it off. And just like with her as well, I decided to put my bigger number to South Block because it's larger, and have the smaller number over in Welch Hall.
Hey.
Awesome. Did anybody else do it a different way, or did everyone kind of do it similarly? Did anyone run into problems?
So I tried to use a really nice, easy, even number that I thought would work. It was 50,000, and I still can't reach my answer. Trying to figure it out. I used as much like mental math as I could and tried to simplify it as much as I could for myself, but the numbers still aren't working out. So this is where that math anxiety starts to kick in, when everybody finishes before you and everyone asks, do you need help? Are you okay? Is everything good? It might actually be the worst feeling ever. But in the classroom setting, you just have to give those students that time and give them the time to think about it and figure it out. Because I'm determined. I know that I could sit here and we don't have the time for me to do that. But in the classroom setting, you have to give kids that time and don't ask them too many questions. It just means that like
They're
working
processing
toward, you're working towards that answer in your own time and at your own pace. And that doesn't mean you're dumber than anyone else in the room.
Absolutely. That's another thing we learned as well throughout the classes and throughout our readings, that math and the speed in which you do math, they don't relate to each other. I always thought personally that like the kids who were good at math could do it quickly. I can still do that same question. It just takes me a little bit. But I think that's like society puts a lot of stress on being fast. If this is a real life skill, you need to do it quickly in the real world or things like that. But it's times like this. Thank you for bringing that up and saying that you did struggle or you had some difficulties along the way, because students kind of need to hear that. They need to hear that these ideas and characteristics and myths being put into their head aren't true, and that they can still have the chance to be successful in math regardless of what their favorite TV show says or what their parents think or how society wants you to be quick. So that's also where differentiated instruction comes in, because everybody was able to work at their own pace and put in their own numbers and kind of solve it their own ways. So now we're going to start to get into our wrap up, but I want to just ask everybody, how did you feel about this differentiated instruction task? Did this seem like differentiated instruction to you? Have you seen this before? How did you feel participating and things like that? I just want to hear just generally how you felt about this exercise and activity.
I personally really liked it, because in general, differentiation sounds like it'd be a really big task, a lot of extra work for us. But this was a really simple way to include differentiation in the class, as in a way that doesn't make any students feel like they're singled out. So to give like a student an easier problem than another one is like almost telling that student it's almost like telling that student you're stupid so you don't get as difficult of a question. Whereas when you're differentiating for all the students like this, it's a good chance not just for some students to make it a bit easier for themselves, but also for other students to make it more difficult for themselves in their life.
Absolutely.
I really liked it too. I've actually never seen anything like this before. I was always given the numbers as a student. And now that we're talking about differentiation, you never think something as simple as just letting them choose their own numbers, I guess, is like just in a word problem is so useful, because if you aren't comfortable, you can just pick a number that you are comfortable with. But if you want to challenge yourself, you can like pick a crazy number. It's really interesting because it differentiates for both levels at the same time, and it's the same question.
Exactly. So they're still learning the same skills they need. They're still knocking off those same curriculum expectations. That's why I was so adamant about putting them at the top, because even though we all did it differently, we're all knocking off those same curriculum connections and applying it to real life and the world around us. And as teachers, what Michael was saying, it seems hard. It seems daunting to differentiate for this student and this student and this student. So this is a really easy way, almost where the students kind of do the work for you. They are differentiating it for themselves. So as long as you're aware of what each student needs for that equality that Sam and Gio brought up earlier, and that equity within the classroom, the inclusivity, you can give them things like this, either challenge themselves or not even play it safe, or just stay in their comfort zone of what they like to do. The more you hand out these differentiated tasks and parallel tasks, the more students will be willing to try. Getting those numbers is super scary. That math anxiety that you had brought up, Geo, is real. I was one of those kids in the class where I wasn't done. I thought I had to do it quickly, and the numbers the teacher gave me didn't really make sense, or they were too big or something. So something as similar as this really kind of weans them on to those questions where it's not differentiated, because in the real world they may be given numbers and the scenario and things like that, but having this opportunity to play around with numbers and actually figure out where they're comfortable and what type of learner they are is really important in the JI setting.
And I really liked being able to choose our own numbers, because now if I did have more time to do this, I realized, this number is confusing me. It's not working for me. So now I can go in, change that number, and rework it, and maybe use a number that I can understand better to get to my answer.
Absolutely.
Did anyone feel different to that? Like, would anyone rather have the numbers, both set of numbers given to them and just solve the problem how it was? Or did you actually all enjoy choosing your own numbers better? Did you find it easier? Did you find it harder?
Mm-hmm.
Were there benefits to having picked your own numbers? Or would you rather just have that question straight up?
I think it was good that it was only one number you're choosing, and that you're giving them something. Because I think some students, if they just saw choose 4 or 5 numbers, they wouldn't even know where to start.
The panic.
Right? Like it would just be like, there's just a lot going, right? So here you're like, okay, I'm only choosing one number, and the rest of it, I know what to work with to kind of figure this out. So I did like that. Yeah, I'm just saying, I feel like if you almost gave them like 6 or like have them choose each of them for somehow, like it would just, kids wouldn't even know where to start, I feel.
Too much.
I think
For
it's
sure.
also interesting that the first thing that Gio said was that she tried to do as much of it as she could mentally, which I think also takes a completely different mindset, because I know we all reach for our calculators, but at the same time we calculate it in our heads differently, I think, than Gio did. So it's like we're all still doing that kind of calculation, but seeing it nice how it was applied differently. And I think a lot of students do that too, and feel like if they're not doing the same thing as their peers, then it's wrong, but that's not true.
Absolutely. So like Shawna was saying, there's no right answer.
Yeah.
You're not looking for a right answer here. You're looking for their problem solving abilities and the way they did it on paper, maybe visually, maybe they didn't quite get it, maybe they had to rework their number, and that's okay. Those are the skills that your brain needs to develop. Absolutely.
We're focusing more on the problem and feeling comfortable about solving it instead of being stressed out and having to just do a straight math question with 2 numbers. You want to focus on the idea of problem solving, and then that way, even though there is no right answer, you're still understanding how you got there. You're still getting your own right answer because you're understanding how you're going about solving that question.
Absolutely.
You already answered everything else.
Cool. Right. Does anyone else have any suggestions or anything else they wanted to say about this, or a way maybe to improve it to different grade levels?
No, it was good.
So that's it for our webinar. I hope we really helped you with differentiated instruction, especially math. It does seem daunting to have to do this for so many students and different skill levels on IEPs and things like that, but this is a really simple way to give kids that importance in math and really help them understand it for themselves and figure out what they like, what they don't, and help them grasp tasks as opposed to just being like, that's scary, I'm not even going to try, because that deters kids from learning math and I think liking math. And I think that's where a lot of students are right now. So awesome. Thank you for joining our webinar, and we'll see you next week.